Now we will discuss some typical conductometry titration curves. The first we will discuss the strong acid with a strong base. Okay, so for example, हमको HCl with NaOH हमको टाइट्रेट करना है और कंडक्टोमेट्री से हम लोग उसको कैसे टाइट्रेट करेंगे. So पहले हम लोग हमारा जो एनालाइट है that is your HCl solution and burette में you will take the NaOH. Okay. So before NaCl is added, अब सबसे पहला पॉइंट यहाँ पर देख सकते हैं कंडक्टेंस इज हाई. तो HCl का जो डिसोसिएशन होगा that is because of presence of highly mobile hydrogen ions. Okay, so ये आपका फर्स्ट स्टार्टिंग पॉइंट हो गया. Now जब भी हम लोग बेस ऐड करना स्टार्ट करेंगे कंडक्टेंस धीरे धीरे कम हो रहा है. You can see this. Okay, this is because of the replacement of hydrogen ions by the added cation H plus ions are reacting with OH minus ions, and that will form undissociated water. So this decrease in the conductance will continue till the equivalence point. और यहाँ पर ये आपका equivalence point आ गया. उसके बाद the solution mainly contains only NaCl. इसके बाद after the equivalence point you can see the conductance increases because of large conductivity of OH minus ions. Okay, so if I plot the graph of conductivity versus so conductance versus the volume of NaOH added, okay, you get a V-shaped curve, and this is your end point. Now let us see the second type of titration, that is the titration of a weak acid with a strong base. For example, we are taking acetic acid and make OH. Now acetic acid is your weak base. Okay, तो weak base है, इसका मतलब इसका आयनाइजेशन जो होगा वो compared to HCl it will be less. तो इनिशियली आप देख सकते हैं यहाँ पर कंडक्टेंस दिस इज 0.1 मोलर सॉल्यूशन ऑफ एसिटिक एसिड, दिस इज 0.01 मोलर, एंड फर्दर आप डाइल्यूट करेंगे इसको तो यू कैन सी द कंडक्टेंस विल बी समवेयर लाइक हियर एट दिस पॉइंट. Okay, so initial because of the feeble ionization of acetic acid the conductance is low. तो जैसे ही आप NaOH उसमें ऐड करेंगे there will be decrease in the conductance not only due to the replacement of H plus ions by Na plus ions, but there is also suppression of the dissociation of acetic acid due to the common ion acetate. तो acetic acid and NaOH के साथ react होने के बाद sodium acetate बनेगा. So common ion acetate की वजह से there is a decrease or suppression of the dissociation of acetic acid. Very soon the conductance increases. Okay, आप देख सकते हैं then the conductance slowly increases because on adding NaOH आपका जो NaOH है that has neutralized the undissociated CH3COOH to sodium acetate, and this is a strong electrolyte. Okay, so जैसे ही आपका NaOH CH3COOH को neutralize करेगा then there is a formation of sodium acetate, और ये sodium acetate is a strong electrolyte. So there is an increase in the conductance, and that continues up to the equivalence point. Okay, so the graph near the equivalence point is curved due to the hydrolysis of the salt CH3COON. Beyond this equivalence point, the conductance rapidly will increase, and that is with the addition of NaOH due to the high conducting OH ions. Next, we will see the strong acid versus a weak base. Okay, suppose I take sulfuric acid and I titrate against with the dilute ammonia solution. So conductance on y-axis and on x-axis we will plot volume of ammonia. So initially the conductance is high, you can see this point. Okay, then it decreases, similar to what we have seen earlier due to the replacement of H plus ions. और यहाँ पर आपका equivalence point reach हो गया है. After the equivalence point, your graph becomes almost straight horizontally because excess ammonia is not appreciably ionized in presence of ammonium acetate. So ammonium acetate की वजह से there will be suppression of the dissociation, and hence you will not see a sharp rise, but there will be a horizontal line seen. Okay, because the excess ammonia is not ionized that much in presence of ammonium acetate. So यहाँ पर भी common ion effect की वजह से the ionization is suppressed. Then we have one more example, that is weak acid versus weak base. Suppose you are taking acetic acid. ये भी weak acid है, and ammonium hydroxide is a weak base. So the nature of the curve before the equivalence point is similar to what we have seen where by titrating weak acid against strong base. Okay, and then after the equivalence point, तो यहाँ पर पहले sharp increase दिख रहा है, and then it will be remaining same. After the equivalence point, ये आपका equivalence point है, यहाँ पर इसके बाद में आपका conductance जो है वो virtually same रहेगा, because weak acid जो है ammonia which is feebly ionized, इसका ionization बहुत कम होगा and therefore it is not much conducting. Okay, so this is a conductometry titration curve of weak acid versus a weak base. Now suppose you have one more example I will discuss, that is your conductometry. You're doing the titration of a mixture of a strong acid HCl. You take a weak acid, that is CH3COOH, and a strong base or a weak base. Okay, so initially you will see a curve like this, then like this, and then it is going up. Okay, so in this curve we have two breakpoints. ये एक हो गया, and this is the another breakpoint. The first breakpoint corresponds to neutralization of the strong acid. जब भी strong acid completely neutralize होगा, only then the weak acid will start neutralizing. Okay, तो second break point जो है, that corresponds to neutralization of weak acid, and after that the conductance increases because of excess of NaOH, because of excess of OH minus ions. अगर हम NaOH के साथ उसको titrate कर रहे हैं, however when the titrant is weak base जैसे इसके NH4OH, okay, तो आपका end equivalence point के बाद ये almost constant रहेगा. Okay, so this is a graph of mixture of strong acid and weak acid versus strong or weak base. तो यहाँ पर हमको दो break points मिलेंगे. Then one more example is displacement titrations. When the salt of weak acid is titrated with the strong acid, the anion of the weak acid will be replaced by the strong acid, and itself it is liberated in the undissociated form. Similarly, in the addition of strong base to the salt of weak base, cation of the weak base will be replaced by that of stronger one, and the weak base itself is generated in the undissociated form. Okay, so we'll see the graph. So we are getting NH4Cl and NaOH. We are getting curve like this. If you are taking CH3COO, Na, that is sodium acetate, and HCl, we are getting curve like this. Okay, so here, first you can see the acetate ion is replaced by chloride ions. Okay, acetate ion is replaced by chloride ions. So this. Okay, so initial increase in the conductivity is due to the conductivity of the chloride ion, which is slightly greater than the acetate ion. So until the replacement is nearly complete, okay, the solution contains enough sodium acetate, and that will suppress ionization of liberated acetic acid, so resulting in a negligible increase in the conductivity. However, near the equivalence point, your acetic acid is sufficiently ionized to affect the conductivity, and a rounded portion of this curve is obtained. Beyond the equivalence point, what is happening? Excess जो भी HCl present है, okay, and because of the ionization of acetic acid is suppressed, conductivity will sharply decrease. Now we will see the last one, precipitation titration and complex formation titration. So reaction may be made on the basis of conductometry precipitation titration, provided the reaction is sparingly soluble or a stable complex. The solubility of the precipitate should be less than 5%. Addition of ethanol is recommended to reduce the solubility of precipitation. So here, if the solubility of the precipitate is negligible, the conductance of the equivalence point should be given by AB and not observed AC. The addition of excess of the reagent depends on the solubility of the precipitate, and if the solubility is not too large, the position of B can be determined by continuing the straight portion of two arms and of the curve until they intersect.